Welcome to today's webinar brought to you by Datavail. I'm Stephen Fegg, Director of Database Trends and Applications and Unisphere Research. I will be your host for today's broadcast. Our presentation today is titled The Next Era of Database Management, Emerging Technologies and Best Practices. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the submit button. We're going to try to get to as many questions as possible later. Now, to introduce our speakers for today, we're very excited to have with us Krishna, Director and Global Practice Lead of MySQL Services at Datavail, Anuj Pandey, Senior Oracle Database Administrator at Datavail, Mike Frank, MySQL Product Management Director at Oracle, and Freddie Hernandez, Multicloud Database Leader at Oracle. We've got a great discussion planned for today. I've got lots of questions I'd like to ask our experts, but first I'm going to hand it over to Krishna for some brief comments on the current database management landscape. Krishna, welcome to the broadcast.
Thank you, Stephen, and welcome everyone. Before we dive in, let's take a quick look at the evolving landscape of database, right? Gartner predictions that the growth for databases is going to be around 16% annually, and you can see the trend. And with graph database and vector database leading the pack. If you focus on the key trends and innovation, it is evident with the rise of an adoption of AI and ML integrations, and for predictive analysis and recommendation systems, right, and the need for real-time data for fraud detection and anomaly detection. It shows up that the growth for graph and vector database, they're going to play a crucial role there. The next one is obviously from DBTA, which is like 62% of organizations are still at the basic database maturity level. I can relate to this one closely. At Datavail, we work with a lot of customers, right, starting from small, medium to large enterprises. And when we do this maturity assessment, and we do that at multiple levels, right, from people, process, and technology. And when we do that assessment, it's very interesting that majority of them are still at the early stages of emerging and adoption level, not even at the developing level. So it shows up that only 88% are mature enough to leverage their AI for their data insights and recommendations. Moving along. 80% of companies are building most of their new applications with thinking cloud in the mind. And we have seen that in the last decade or so, and with majority of open source databases picking up the momentum, and lots of applications are leveraging within the cloud, whether it's platform as a service or database as a service. And cloud not only enabled organizations, but it also empowered and transformed their businesses to focus on growth, innovation, and opening up lots of opportunities for the greater scale. And as all with any innovation, right, it comes with certain challenges with respect to performance, cost optimization, scalability, and we're going to touch briefly on some of those in our today's discussion. If you look at the next one, 87% of those business leaders see their data system, they're ready to build it, but they're busy with doing their day-to-day activities or focusing on data management aspects, whether it's data preparation, the anomaly in the data, and preparing their data for real-time trends analysis. So it's pretty evident that there's certainly a lot of opportunity for both database and data management aspects of it. With that, let's dive into some of the discussion topics for today. Back to you, Stephen.
On the board here. Okay, so we're going to dive into our questions for today. All right, first question. And Anuj, I'm going to pose this to you first. What are some of the biggest challenges enterprises face with traditional database today as far as modern workloads?
Hi, Stephen. Thank you for giving that question to me. Yeah, so the most important points I see is like scalability with the existing database, the data centers, if you want to provision one database servers, it takes close to 3 weeks to 6 weeks to provision one database servers if it is in-prem database servers. Whereas if you go to cloud, any cloud platforms, you can just build the databases or database servers just in 15 to 30 minutes, provided all the networks and infrastructure is created in advance. Like I have customers, they needed a database to be migrated to Oracle Autonomous Database, and they requested, hey, I need to migrate these databases because the existing databases, the data center that we have, it's so expensive right now because the database has grown up close to 13 terabytes. And when they're trying to increase the CPUs and other resources, it's always running short. So they keep adding the resources, but still they are running short of resources. So they were going to Exadata system in Oracle database platforms. There they added 2-node cluster, and eventually they increased 4-node cluster. And that cluster, increasing those clusters nodes, it was just you order to Oracle support, and then they will have paper work done, and then they would add the 2 nodes into the cluster, and we can simply scale just in a day or two. Whereas if you go for in-prem, it takes weeks and weeks to get the servers from the Oracle and install, set up all the stuff. So one is scalability, second is performance bottlenecks. Performance bottleneck right now, I have the database that's running in ATP, and in morning between 8 a.m. to 12 a.m., 12 p.m. actually, we have heavy load on that system, and after that we are so low on the load point of view. So what we do is we increase the number of CPUs and memories on the database. We make it 40 to 80, and once done, we bring it back for the rest of the day. So that's our regular maintenance task that we are doing. So we are able to fit the challenges that we have about the resource bottleneck, performance, high CPU utilization. In the cloud system, simply we can just go click, add 80, add 40 CPUs, done, boom, that's it. So that's second advantage I see when we are migrating to cloud database systems. In regards to maintenance complexity, for database servers, we need system engineers, network engineers, and database engineers. All three team members works together to build one system, and that takes weeks and weeks. In the ATP database, if I take an example as an Oracle, I'm an Oracle expert, so I create the database just in 7 minutes in ATP database, and I can take care of all the firewall roles, all the connectivity, internet, internet access. So that was that complexity is gone. Just create the database, and rest everything is taken care by cloud providers. Then the cost effectiveness, like I was talking on the second point about the performance bottleneck. We don't have to retain the same resources all the time. You need it, you add the resources, you're done. So that sort of advantages we have.
Understood.
Yeah.
I mean, there are a lot
of many things.
Oh, I'm sorry.
Yeah, go ahead.
No, I was just I was going to see if Krishna wanted to add anything to that.
Sure. I mean, we're talking about the challenges, right? I mean, majority of the customers that we work with, right? It's the biggest challenge is the migration of data itself, right? You need to plan and account for some of the maintenance activities and make sure business are not disruptive, right? At the same time, there are a lot of variety of database options to choose on the cloud, and you need to choose the right database for the right solution, and having the right knowledge skill set for the people to be able to migrate, not just migrate, but also continue to support them. And at Datavail, we kind of do kind of both migrations and modernization and continue to support them as well. So I think lack of skill set and knowledge and being aware of what options and opportunities are available in the cloud is also one of the main concerns or kind of challenges. But yeah.
Absolutely. Mike, as a MySQL guy, I'm curious what your thoughts are on this.
Yeah, I've got a few different thoughts. And my bent has always been in the security side of things for a long time. And one of the challenges I see is the lack of attention to security in there's this sort of friction between application developers and how they manage the identity of users using their system, and how those systems come into the MySQL database. And that is where a lot of the issues out there on the cybersecurity side are. It's simple, the blocking and tackling of identity management. So I would say that seems to be a big challenge. DBAs don't tend to understand the identity management systems, LDAPs, Active Directories, the other options. And so there tends to be some need to work across teams and things like that I see commonly, and just even trying to get people to upgrade to a stronger hash, it seems to be painful for a lot of folks. MySQL has always been good at horizontal scaling on the read-only side, right? And so we saw people struggling with that. Big companies, big unicorns were always able to put hundreds of engineers on these sort of systems to develop them. But in the case of MySQL, we developed sort of got into the DevOps side to try to make that easier to do. And so I think one of the challenges is to operating a herd of databases versus single databases at a time, and no longer can you just try to look at it at a single point. Obviously, we're going to talk a bit more, I know, about some of the multi-model and things like that. But having silos of data all over the place is a problem, especially when you need to sort of join that data together to do some sort of analysis. But I do think there's some really good new standards out there, things like OpenTelemetry, things like Kubernetes, things like OpenID that are really going to help bridge some of these gaps. And I think a lot of the challenges do at this point require some standardization, and we're seeing that happening through things like Cloud Native Compute Foundation and things like that.
That's a great point. Standards are going to be important, and both security and data silos seem like they're going to be issues that need to be hashed out, especially as lots of organizations increasingly focus on leveraging their data for AI initiatives. That's going to become important. Freddie, I haven't forgotten about you. I'm curious your thoughts on this question as somebody that's focused on multi-cloud.
Well, definitely, I have to agree with Mike. The cybersecurity part of it's very relevant nowadays. For the same things that Mike mentioned, right? You need to make sure that your data is prepared to resist any attacks. Make sure you protect your data with all the safeguards, and that you have a good method and process to detect cybersecurity threats and breaches. Now, but that needs to be complemented with the business continuity side of it, because how do you respond to a security breach, right? So you need to create your response plan. You need to make sure that you're able to not only continue to your business as usual, but in case of a strong enough attack, how can you recover from that attack? So it's a whole life cycle in terms of the security aspect. And on top of that, you have to deal with data that is everywhere, right? So you have to, it's not like your database is in your data center only, and you just needed to protect those four walls. Now your data might be well beyond that in different clouds and different providers. So you need to extend your process to all that life cycle that I just talked about, that I call like the cyber resilience, right? So it's all the cybersecurity issues, but the business continuity issues that you need to consider.
That's a great point, Freddie. Data is so much more distributed nowadays. It's not just sitting inside one database or even multiple databases on-prem. So I think we'll see a lot more attention on that as well. All right, we're going to move on to our next question for today. Krishna, I'm going to let you bat first on this question. Modern applications require support for diverse data types. What role do databases play in managing them?
Well, and as I mentioned, right, there are multiple data types, right? We're talking about structured data. I mean, traditionally, we've been using structured data for quite a long period, right? And those are not sufficient to accommodate the modern workload types, right? We have now unstructured data, semi-structured data. We're talking about AI ML integration. So we have images, we have text, and we have IoT sensor data coming along. So there's a lot of data. And to be frank, I would say most of the organizations realize that the amount of structured data they have versus the amount of unstructured data they have, there's a huge difference. And the best way to analyze it and make use of the data is becoming a very big challenge, so we can bring productive results and faster responses to make business decisions effectively out of the data.
Understood. Freddie, what are your thoughts on this as far as roles, and if roles are evolving in this area?
Well, I have a couple of takes on this. So having different data types is not the main complexity. I think we're getting used to it. That's how we have responded to the evolution of content, right? Creating different types of data. I think the problem begins when we need to manage those distinct types of data, and even more when we need to be able to have systems and different applications that need to communicate with those different types of data. So it can get very complex to manage and maintain those different systems and worry about the topics that we just talked about, security and so on and so forth. So that's why you need to start thinking of how can you start combining some of those systems that support different data types. I think here in the Oracle database, that's what we call the converged database, right? It's kind of an abstract concept, but it's allowing you to, for example, use JSON documents, to give you flexibility in the type of data that you handle, or being able to handle spatial data in the same database for location awareness of the data, or IoT, and being able to do analytics for that on that data. That, of course, on top of the traditional relational database that you're used to manage. So you want to have a converged database that can help you run as many of those types of workloads, and not only on the types of data, but different types of databases or architecture, like having distributed databases that nowadays is becoming so relevant, having blockchain even interpreted inside the same database, and how connecting to microservice and machine learning and all that. So that's really what we've been working on, the Oracle database, and that's kind of the vision that we want to help make those modern applications that can handle all these type of use cases. We have now things like the JSON reality duality that helps you see JSON documents in relational tables. So or handling graphs, to make those powerful connections between data. So there is really a good benefit if you're able to run any type of workload in a single database. And remember that there are databases that you use for transaction, and there are databases that you use for data warehouse or mixed. So I believe that's the best approach for a database can play in managing diverse data types.
Understood. And yeah, in recent years, since big data became kind of a big concept that was kind of on the tips of everyone's tongues, we've seen the proliferation of lots of different types of databases as well as data architecture patterns. So that's interesting to hear. Mike, what are your thoughts on this?
Well, I share a lot of the same thoughts, and obviously we're both with Oracle, and so there's some shared brainstorming across the teams. On the MySQL and the OCI side, we have what we call HeatWave, which is a MySQL system that can handle all these different data types. And it's not just data types, but it's also, and I think Freddie may have mentioned this, but it's also the type of processing you do on that data. And so, in the past, you had an OLTP system, right? MySQL, obviously the NRDB database engine, very good at doing ACID, commits, high volume of inserts, even higher volumes of reads. But now we need to, in real time, be able to process and do analytics on that data without totally hammering the main database, right? Or even hammering too much, in the case of MySQL, our read-only replicas and things like that. And so this is where we've, added these OLAP and machine learning and AI processing, where the data is persisted within the MySQL NODB. It's locked in, it's ACID and all that. But at the same time, I can go and do processing on that data and not have a horrible side effect on my OLTP side. So again, there's the structured, unstructured, and semi-structured, which you get from things like data lakes and warehouses and things like that. At the same time, there's the real-time data you're getting from these OLTP systems that you don't have to wait a day or two or three to ETL it off to some other system that can do analytics on it, but instead be able to do it on that system and not take a huge performance hit. And so I think that's sort of the future from a security standpoint. Obviously, too, this is the management of data going every which way, and the cost. You can't factor out cost on these type of things, and the cost of having to create and spread this data all over the place, especially from an engineering standpoint, is just very high.
Cost is definitely a big issue, and I'm glad you brought up real time. It seems like there's an increasing demand for that, whether folks really need it or not. Everybody wants data instantly. All right, we're going to move to our next question. And Anush, why don't we start with you on this? What are the biggest hurdles organizations face when migrating to cloud native databases, and how do you overcome those?
In cloud, we have so much restrictions along with so much offerings we have. And to accommodate all those restrictions, I think we have to work through all those, whatever they are offering in the databases side, because right now we have different kind of databases like serverless. And right now, all the DBAs, they are mostly comfortable with the logging to the systems and perform all their activities. But now when we have the serverless, there's just so much challenges how to monitor those databases, how to integrate our daily routines, activities, jobs. Likewise, jobs. Integration of the jobs is one of the big thing I see on my Oracle database sites. And when we are migrating the database to ATP, it's a pluggable database, not a full-fledged databases that we get it. And the major rule for DBS also, they have excluded all the database roles sort of stuff. So we have to learn and do it all those database permissions issues, and many data types are not supporting, many kind of objects are not being supported. So all those things we are working out with Oracle to fix those sort of issues. So
understood. Krishna would love
Yeah.
your viewpoint on this as well.
Absolutely. I think, going back to having a clear migration plan and, plan of action is going to be crucial. Otherwise, obviously nothing is going to be successful there. And having time and resources, right? Most of our organizations, they're busy focusing on doing their day-to-day work, and probably, engaging a partner like a vendor, maybe and helping with this migration journey is going to be definitely helpful. So the in-house teams can focus on their business requirements and focus on their innovation stuff, and that's going to help those organizations so that they can strategize and work with the other partner to help with the migration strategy. And another thing is, the cost, of course, plays a major role, and choosing the right solution at the same time, having the right skill set, and able to, have the security measures in place, especially, with organizations moving towards multi-cloud and hybrid cloud approaches, right? Having those security compliance regulations and staying the data where it needs to be is one of the biggest concerns for sure.
Understood. Mike, would love your viewpoint on this. What do you see as the biggest hurdles right now?
It's kind of interesting. So on the migration side, we've noted that a lot of our tools didn't move data fast enough, and so we added a lot of parallelization. We added the ability to turn off redo archiving, where it's a situation where you don't have to recover if you don't get everything moved, and then you turn that back on. A lot of our customers, when they're migrating, it's actually a migration and an upgrade because they're on such old versions on-prem. And the Oracle database is certainly better about that than we are, right? They have more advanced capabilities to back support things, but with MySQL, that can be a little more effort there. Then there's the whole issue with sort of privilege abuse and accounts that they're trying to move over that have way too many privileges that overlap into things that we do in the cloud. And so folks have to adjust those sorts of things. And what else? Yeah, and I guess just finally, often you see where database controls and applications, administrative things are too intertwined. And so as process of moving to the cloud, where all that's taken care of you, those things sort of expose themselves. And so these are things that people, it's a good thing because it forces people to upgrade, it forces them to improve their security, but it adds stiction to the process, right? Those are the sorts of things that, and again, it's just the volume of data often can take a while.
Understood. Freddie, is this what you're seeing as well?
Definitely, I think migration is one of the main issues, and not just because of the migration itself, is because what I see is users have to kind of re-platform their whole application to adopt these cloud native services, right? So that's a huge effort for the database and for the application, and I think there are better processes out there that are more standard, because if you, let's say you choose a specific cloud provider for your database service or your application service, then you're kind of stuck with them because you already made all this effort to re-platform into that cloud. So just thinking about moving it somewhere else is a whole other effort. Probably the same services are not available in the other cloud. So you need to start thinking about how can you use the best platform that is available to use in the most places that you need, right? So especially now with the whole multi-cloud and hybrid cloud, you want to make sure you can use the same type of features and libraries and sets of data that you use in any cloud or on premise, and I think that's one of the major hurdles that it's affecting the whole implementation of cloud native environments.
Getting some consistency and some kind of standards in place, so it's not just reinventing the wheel each time. Especially, I would think with multi-cloud environments, the complexity would go up in those scenarios. Okay, Anuj, I'm going to let you lead off with this next question. How do distributed databases handle high availability and disaster recovery in real-time use cases?
Yeah, so the disaster recovery and high availability both goes hand to hand. And first of all, most of the customers, they focus on high availability, and for that, most of the time they are going for in Oracle, they go for real application cluster, which gives you high availability fault tolerance, where if one of the node is crashed or went off, we have other surviving nodes and they can work on it. And for DR in high availability, it comes as a DR also. So for disaster recovery, let's say we have data center one in Phoenix and other is in different places. And if something happened in Phoenix side, we have same database replicated to other data centers. So that's how most of the customers are going. They are configuring clusters, database clusters, and they are doing a database disaster recovery. On top of it, we have real-time replications where, like I have one of the customer, they have databases running in autonomous database, and their replication nodes running in AWS cloud, and that is microservices. Microservices is it gives zero latency. So whatever data you enter here in the Oracle platforms, it goes and replicates same data to AWS side. And on Oracle side, we have a DR and Oracle RAC. On AWS side, we have a cluster replication nodes. So we have 3 levels of failures: one for disaster recovery and another for real application database, which can be they have configured automatic failover, so we can simply switch. The database simply can switch to the replication nodes with no time. We have something called fast start failover. If the primary nodes is not accessible for certain seconds, it switches all the applications automatically to the not surviving nodes, the DR side or replication side based on your priority. So that's one. And in the distributed side, all the like we have the users across the globe, and using cloud features, we can have the data available whatever the zones they are. So we can reduce the latency on the data fetch and access response time. So that's how most of my customers die.
Understood. I appreciate your insights on that. Mike, given your focus on MySQL, curious for your thoughts, how you'd respond to this question. And then Krishna, I'll let you go next.
Yeah, so MySQL for a long time, right, has been really strong on the replication side, and this was based on really the need for read scale out and these unicorns. But in general, that read scale out is a disaster recovery type of scenario, because you can upgrade replicas and have them take over if you lose something. So, but that was all sort of a technology versus products. And so, product-wise, we have what is called the NRB clusters, which is the HA, the MySQL replica set, which is the DR. And then if you need, HA and 2 data centers with disaster recovery from one to another, we have the MySQL cluster set. And so these are all shared nothing architectures. You can lose a node. In the case of the HA, right, that it uses a Paxos algorithm to decide when a node is lost and who takes over. The system has the DevOps to bring up new nodes and things like that. This disaster recovery, you can use it locally, but it's also used for read scale out, but you can also use it for, geographic replication and things like that. And often that's needed. And so, so we've got all this stuff. Now, the nice part is that, even though we've made it easier, it's not easy to do HA. It's not easy to do disaster recovery. You have to practice these things. You have to have policies and procedures for that. The nice thing of the cloud is that these are all just a click a button options for things. And now you've got this or that for, HA or DR or both those sorts of things. And so it really, the cloud really, really simplifies those sorts of things on the HA and the DR. And in addition to that, obviously, the Oracle Cloud has all kinds of redundancy for storage, for networking, all those sorts of things. So you really get a very, very high availability in that sort of thing. So there's a lot to offer from the MySQL side. We've been doing this sort of a virtual bin log replication for a very, very long time. And with these sorts of things too, you can do rolling upgrades and all those sorts of things that could affect availability, but don't have to with these sort of methods. And so the upgrade thing is always the thing that sort of puts a knock in the high availability sometimes, whether it's the operating system or the database system. But with these, support for these rolling upgrades, either in the cluster or replica sets, it allows you to just continually operate 24/7.
Understood. Thanks, Mike. Krishna, you wanted to add something here as well.
Sure. Yeah, I totally agree with Mike and Anuj on that. But let's take the purpose of distributed databases is having it locally available close to your user base, right? At the same time, making sure high availability and disaster recovery you're compliant with is obviously, I think, one of the best ways is to see if you could decentralize and decouple and shift it into a more microservices architecture. So in case you still have a kind of a failure or kind of minimizing that impact overall. So I think that's one of the key frameworks to consider looking into. Hey, you still have a minimal set of resources, and at the same time, we always aim for zero latency, right? So closing to the business, closing to the users. At the same time, I think having that distributed microservices architecture methodology within the design level is certainly going to help.
Absolutely. We're on to our next question. Freddie, I'm going to let you lead off with this one. With many organizations moving towards hybrid and multi-cloud strategies, how does it impact the scalability and performance of database systems?
All right. I like that question because that's kind of my area that I've been working on for the past year or so. So I have a couple of takes on these. So the first is that application architectures and the capabilities are really driving those hybrid and multi-cloud strategies, right? So the architecture you choose and the database that you choose that makes a difference. So we have seen the evolution of from the monolithic environments to a more now decentralized distributed architectures that we just talked about. So I think we've been concentrating actually both approaches. We're trying to do the monolithic applications, such as the microservices, where we provide simpler integration of the database transactions with those services, right? So in the Oracle database, we provide those transaction event queues to help with that, kind of try to eliminate those middle brokers or event brokers that we're using, like Kafka and all that. So we're trying to simplify that. And then on the distributed, when you go to the distributed databases, we want to present the database to be able to manage it as a logical single database, but having the data distributed, right? This can serve the scalability purpose and the availability purposes, but you can have it anywhere you want, in any cloud, for example. So that's the first angle. So you need to choose the right architecture for your needs, and maybe it's a combination of both, depending. So now the other angle has to do more with the performance and the scalability and the security of your environment. And it really boils down to the infrastructure, the underlying infrastructure where you're running these services. So, for example, what do you do if you're running your database on premises in your data center, and you want to start moving to the cloud, right? Or you want to do disaster recovery in the cloud, whatever. So you could, like we talked before, you could start re-platform your application, try to adapt it to the existing environment that's available in that cloud. But that's really not the ideal, because then you're limiting you're basically limited to the services that are available in those clouds and the features that you could use in your database when you move it to those clouds. I'll give you an example. For example, if you're using Oracle database and you're using real application cluster rack on premises, when you take those to a third-party cloud rack, so that's a limitation. If you go to a third-party cloud, running it on VMs or bare metals, you're not going to be able to run the latest version, 23 AI, of the Oracle database. So those are real limitations that you need to consider. What you need to start doing is standardizing in homogeneous platforms that are available anywhere you want it. That's how you start really thinking about moving efficiently towards a hybrid or multi-cloud architecture. That is what we've been working on, not only from this database standpoint, but from the platform. I don't know if you saw in the beginning. So I've seen the whole evolution of the Oracle Exadata platform. I came from Sun Microsystems, and I've seen the evolution of the platform, where now you run the Oracle database on the Exadata platform, and you can run it anywhere you want. It's the same platform. You can run it on premises, you purchase it, you put it in your data center, or now we put that platform to run the Oracle database in the cloud. Could be our cloud, or this year we've been putting it in Microsoft, and in Google, and now just recently in AWS. So you can subscribe to the services for the database, and it's the same type of platform that you would use if you're in any of the clouds. So there is a standardization that can help you move between different environments, and that's what really enables you to have a hybrid environment. So those are some of the considerations when you think about how you scale and how is your performance in one cloud or the other, or your limitation. So you shouldn't be concerned with those limitations, really. I think it boils down to, you need to choose the right platform that gives you the choice that you need for the environments that you need.
Absolutely. Thank you, Freddie. Anuj, I wanted to let you, answer this question. I'm curious what your thoughts and your insights on this are.
Yeah. So impact, the way I see is it has made many what to say, many engineers, the software engineers and whoever supports this IT, it has made the life so much easy because scalability is the big thing for any organization, growing organization. So with the moving to the cloud, you have unlimited resources to grow with no time. Again, we have one customer. They had last year 45 resources. Now they are close to 500. And they came to us, hey, we are keep growing and we are not able to take care of our growth internally. So we need a help from Datavail, and please look into that. So um, migrated all the databases to Oracle cloud platforms. Still, they are facing so much issues, but they are able to keep up just because they can simply scale their systems, resources, whatever it required. However, scaling is not only options because you keep scaling, you do not do the kind of archiving process. That's a challenge I'm seeing. The advantage is you can scale the system just like that, but keep scaling, it grows so big that it's not easy to handle, and that's what happened with that customer. So you need smart scaling. You scale it, but see, do we really need to scale? Because storage, IOPS, CPUs, everything has a license and their cost and expenses. I mean, it has costs and pros both, but I see this the scalability, the good features, and we can just scale the database servers or any compute instances just like that, and you just need to be careful when we're scaling. You don't keep a scale because the database's actual database size is like 2 terabytes, and he has scaled it up to 30 terabytes, and that is in the one of the PaaS system, platform as a service. And once you scale the systems over there in Oracle, you cannot bring it down. So now he has problems, and he want to go to ATP where we can scale up and scale down the storage, because he has a 16 terabytes or 18 terabytes of database, whereas the actual data is just 1.2 terabytes. So he's paying the cost for 16 terabytes. So that's one thing I see. And then the performance is really good with going with the cloud systems, and we can reduce the latencies by putting all the data wherever the users are there. We have something called partitioning. We can partition by zone, by country, and we can have that partition sitting on that particular zone. So we can have the better response time. But there's issues like one, smart scaling you need to have. Then we have data consistencies. You might see that. And then latency, data latency, when you are fetching the data from different time zone, different cloud. When we have the class platforms, the big challenge I'm seeing is data latency. I was talking on the first or second question that we have a database in Oracle Cloud, we have a database in AWS, and we always had a challenge for latency. So, I mean, we have some issues along with the, 80-20 ratio, I would say. 80% we have advantage, 20% we have some bottlenecks that we need to overcome by playing smart.
Got it. Thank you very much, Anuj. All right, we're moving on to another question. And Krishna, I'm going to let you lead off with this one. How can next generation databases optimize performance for real-time analytics without sacrificing reliability?
So I think one of the biggest concerns is, the latencies, right? With lots of data coming in, and lots of ETL jobs. And again, as Mike mentioned, security is a major concern as we move data from one system to other system, or one service to other system, and there you're duplicating it, you're risking your data. There is cost associated, and the time consumption it's going to take with all three pipelines to get into, right? So having that real-time capability of driving result sets and meaningful result sets is going to be the key aspect of it. And of course, at the same time, right, when you talk about multi-cloud strategy, Wes, on that front, there are latencies on the front. You have data reliability issues, right? You have to make sure the data you have from one system to other is consistent. And I think that certainly adds a lot of complexity. So if you have a system that could probably eliminate that ETL process altogether, like for an example, like we talk about HTAP systems, right? Hybrid transaction analytics, and I know HeatWave kind of does that, which is awesome. So you don't have to rely on external ETL tools. So I think that's a good initiative moving forward.
Understood. Thank you, Krishna. Mike, why don't we go to you? What are your thoughts on this question?
Yeah, so I do agree. Latency is part of it. We have gone in with customers that have put into place, systems with HA, with DR, and all that kind of stuff. But we're talking about the real-time analytics, right, and the reliability. And so, again, I think a lot of these systems that have been developed for analytics often have a more relaxed model for commits of data, and when you turn on certain things for reliability, there is a cost at the negotiation level of what you're doing. But then if you go in like we did with HeatWave or with some of the Oracle things, where you can use a separate analytics engine that's got a real-time copy in memory and a columnar store in our case of the data, right? So you get best of both worlds. So I hit the columnar store, I hit the in-memory data, I get my answers back immediately. At the same time, all my online transaction processing happening, and I don't lose any data. And then you have the HA obviously set up to where you can do real-time failover on all these things, but all the data has been replicated into these your analytic system and your other system, and it's all transparent to the end user. And so this really takes removes the sacrifice of reliability from things by doing it that way, versus having to update into systems where they don't have strong asset, and then you've got to copy it over. It's not real time. So I think Oracle thinks this is really the way to go, and I think it really does simplify things a great deal.
Absolutely, it sounds like it. Freddie, anything you'd like to add on this question?
Okay, so just I guess adding to Mike, or actually raising the level of Mike's position, a little more radical. I think you shouldn't need to worry about that. You need to choose the right platform that has the underlying performance and the underlying features that would help you achieve those goals, reliability or performance. Some of the things that Mike mentioned, right? The hybrid columnar compression, that should be part of your underlying platform or database. You shouldn't need to start configuring that or having the automatic indexing, not wasting time on that. Having the most used tables, put automatically in Flash or cache to be able to access them quickly. So those things, you shouldn't need to configure it. It should be part of your platform. And I think we need to start trying to implement systems and products and databases and applications that are already doing that. That would take the whole complexity away, and you just need to worry about, managing the data, not the underlying pieces of it.
Understood. Anuj, I'm curious how you would approach this since you're an Oracle DBA.
Yeah, so in Oracle, we have a great offering called in-memory database, and as Mike said, we have row and columnar-based tables we can create for analytics. And I had one great webinar session maybe a couple months ago where I presented about in-memory database where we can have analytics tables kept into columnar format, and we can use it just like that and get the most uh, reliable and performance out of it. So I think Oracle has a great offering on that, and it really works well. I have tested, and some of my customers, they are using it.
Okay, Mike, I've got a question. You brought up security before, so I've got a question for you. How can next-gen databases proactively protect against emerging cybersecurity threats?
Yeah, I think it's harder. And the reason I think it's harder is because of the sheer scale and the whole distributed nature of where your data is. And we call them DB systems, right? It's a system of databases that work together. And so the problem is that, if there's attacks or things like that, traditionally, right, you've got these silos of your performance data or your log data or your audit log for who connected to what, but it's per system. And so what we did inside of MySQL was we added the open telemetry support, which is a cloud native compute foundation thing. And really what you want to do is unsilo that data. And so, for example, we have 400 possible metrics that we can emit. Some of those metrics are just simple counters of, drop table, create user, all those sorts of things, right? Very small integer type things. The key is to stream those into a smart system. In OCI, we have the observability and management products that, for example, the Metric Explorer can look for anomalies and that sort of thing and send you an alert. Or and then the other case we see often is that and some customers are like, we got something going on. We got 10,000 databases. We got microservices. I can't tell where this thing is coming from. And so for that, the open telemetry tracing is very valuable because then we can, the tracing allows you to connect through an ID through the whole stack of your operations. And so say you notice something strange with your metrics, then you can turn on tracing, get a full stack analysis and go, oh, well, this is coming from here, right? This is the bad guy, or this is the misbehaving application. And then on your logs, it's sort of the same deal, right? So I may be getting errors that are distributed across different systems. And so aggregating those logs into something like a log analytics platform like Oracle has for OCI. But obviously there are other metrics, trace and log aggregation products. But these things all are building in AI. They're looking for anomalies. Anomalies often identify some issue that you need to look at. And I think it's really key to realize you can't look at this stuff as a human. We need systems that absorb all this, what the dials are saying on all these things and sort of use artificial intelligence to give us ideas of what might be going on. And then obviously a human can go in and look and see what they need to do. But I think that's sort of a key to cybersecurity because these threat actors are very smart. They'll spread their things out. They'll go low and slow, and having applications that can look at that for us is very important. And so you have to wire that into the database.
I think that's a great point, Mike, and I'm glad you brought up AI because it's a great segue into our next question. And Mike, why don't we start with you? How is the rise of AI and ML reshaping database management systems, and how do they change traditional database management paradigms?
It is kind of interesting because not only is it good to analyze a customer's data to provide them insight into their business, but it's also good at looking at how to automatically manage these systems. And so, it was brought up earlier, DBAs don't they don't want to spend time trying to optimize performance. They don't want to spend time trying to figure out if they have security set up right or all these sort of things. And so using AI internally in our systems, in our HeatWave MySQL system, for example, allows us to automatically give guidance to customers. Hey, just run this create index, or do this or that, or do a lot of things under the hood that they don't even realize they need, that makes no change to how their applications, but AI really gets rid of these really laborsome things that, when I was 30 years ago doing, direct DBA work and just trying to find performance issues, it could take days on end, right? But I was just working on one or two servers. Right now, we've got hundreds or thousands. And so the only way really to attack this is through, I think, intelligent systems working on the databases.
That's a great point, Mike. And I like that, your story is basically AI and automation. They're not really a threat, to database administration or database management at this point. They're basically a friend. They're an ally to help you get more done. Anuj, what are your thoughts?
Yeah, I'll cover 2 points. First, proactive database management from a database security point of view, and then I'll go to this one. I just want to highlight a couple things that Oracle has, something called database vault and a database firewall, and that 2 things I would like to highlight here. I know 60-70% DBAs in Oracle database, they are not using it, and these are 2 things that makes database so secure that we can at database level, we can like firewall settings we can do, where we can specify what database, what OS user, what Oracle database account, from which servers, from which subnet they can connect to database. So we restrict so much, we eliminate so much of threats there itself, because we know what kind of connections can come to database, and that restrict the whole database level. We can put that kind of restrictions, and no one can connect to database, and that's a database vault. And then we have unified editing and table space encryption, where we need a wallet, something called wallet, that we encrypt all the table space with the help of wallet. And if someone is stealing the backups or sort of stuff, they need a wallet along with the passwords. So that sort of things we have Oracle offers. And I'll come to this question, the AI and ML. Oracle has integrated these features so much in autonomous database. We have close to in real time. I saw yesterday one of the autonomous database, they created 1100 indexes, AI underscore something, and that is just to check if I put this indexes, how much performance I'm going to get. They created all those indexes and tested the SQLs internally without giving any instruction from outside. And whatever the best response they got out of those SQLs using AI created index, they kept those indexes active, and the rest other indexes that was created on that table, they made it unusable. So we cannot use it. Sometimes if there's a different SQL statements coming and that required that index, simply the AI is learned, okay, for this one I need these columns, so I'm going to activate this index. So they make it another index unusable and make this index usable, and the SQL just run like that. And they do it most of the time when they see, okay, this is the insert operation, we don't need so much indexes right now to increase the performance. They just disable those indexes. So AI and ML, it's helping so much, and Oracle has integrated this one so nicely, and I really like it.
Good to hear. Krishna, how do you feel that AI and ML are reshaping database management systems and the whole paradigm?
I think I second that with the rest of the panel, where having in database AI and ML integrations is definitely going to help not just the external prediction, but the internal prediction of database, right? How it's performing, what are some of those slow performing queries, what are the best ways to tune them, tweak them, and security point of it, what are any threats, and it gives more flexibility. At the same time, we kind of eliminating the delays of those external ETL process, so you can perform all of those things within the same data layer itself, right? And of course, even the capacity planning stuff, right? Database can analyze, okay, how much are we growing, at what rate are we growing, and what else we need to be prepared for the peak loads timeframes that we normally have. So I think it's a good initiation for sure. But at the same time, we have to make sure that the proper security controls and measures are in place on how the data is being transformed.
Understood. Freddie, curious for your thoughts on this and how this might intersect with what you work on in Multicloud.
So on one hand, we're seeing the AI and Gen AI, machine learning embedded into some of the applications in analytics process. For example, we have in Oracle Analytics, we use machine learning algorithms to make predictions and trends, right? Or, for example, we have an AI assistant to help translate natural language into queries, right? So that's one aspect of it, just using AI as part of your existing applications, kind of integrating it and helping there. Now, on the other hand, what we're seeing is trends to help AI generate SQL code from natural language, right? So that's basically just using LLMs and vector databases to help understand the semantic content of the data and produce a code or a piece of an application. So I know there is a lot of vector databases out there and probably hundreds of LLMs, but really what we're trying to do is not implement more databases and more LLMs. We're trying to do is integrate that into the business application, right? We need to extend those capabilities of the business applications to help with understanding that the data that's needed and how to produce code from it. So I think the goal towards what I've seen in that the development teams are working on is working on creating this AI to help generate applications. We're starting to see that with Oracle Apex. It's part of the Oracle database, and it helps create low-code app development. So that's kind of the starting point. But to generate like more complex applications, I think we're still a way off. We need to have more AI-centric development, right? That can read all the little pieces and help generate the development in the pieces and understands the whole thing to integrate it. But that's certainly something that's coming, and that's where we see things are going.
That's really interesting. I thought we might run late on this one because there's just so much to talk about with respect to the next era of database management. But thankfully, just about all the attendees have stayed with us far beyond the bell. So I'm going to take advantage, and I appreciate you staying with us too. I want to do a lightning round, quick answers. If there's one thing you would really like our attendees to walk away today, keeping in mind, what would that be? Mike, let's start with you.
Oh, you put me on the hot spot.
I'm sorry.
Well, I think that our customers really, I'm a security guy, so you really need to think more about security. Oracle is a member of the Center for Internet Security. I spent a huge amount of time writing the MySQL CIS benchmark. So I would encourage people, go through that. It'll help you de-risk your environment and show you how to do it. And that's it.
Fantastic. Krishna, you're next.
So I would say, AI and ML with all these advancements in innovation, right? It can be applicable and applied to any industry, right? Not just specific to one or two, where you have large data processing, where you have large information of data that you need to process, analyze, and provide the real-time fraud detection or anomaly detection or even patient information, you name it. It can be applied to any industry, and database is going to play a crucial role, especially with building those RAG modules. So you can combine the internal data and the external data and learn more about the internal organizational stuff. So that way you can provide better results. To summarize,
I agree 100%. Freddie, your final takeaway for today.
So as we start to go into this distributed world, right, multi-clouds, hybrid clouds, we have to start thinking of how we choose carefully the right platforms to start standardizing into the correct database, into the correct platform that can help you grow and scale. And like I said before, take care of some of those underlying items that had to worry about the availability and security. In the DBA world, we shouldn't be worrying about that. We should be worrying about how to best manage the data and helping our organizations grow. So that's where choosing the right platforms and services that can move across different parts of the architecture, multi-cloud architecture, are beneficial. So just think carefully about that.
Understood. Anuj, last but not least, what's your key takeaway for today that you'd like to leave us with?
Yeah, I think the most challenging things that I see in the today's world is cybersecurity. So I think we should take care of database cybersecurity with the help of AI and ML. And because I see database load, autonomous databases are taking care of most of the DBS job. The only thing that we need to take care is make sure that database is secured and we don't have any internal or external threats on those. And we need to implement everything that we could do.
I think that's a great point. All right. Well, I would like to give a huge thank you to our speakers today for coming on board and sharing their insights and expertise. One more time, Krishna, Director and Global Practice Lead of MySQL Services at Datavail. Anuj Pandey, Senior Oracle Database Administrator at Datavail. Mike Frank, MySQL Product Management Director at Oracle. And Freddie Hernandez, Multicloud Database Leader at Oracle. If you in attendance with us would like to review this presentation or send it to a colleague, you can use the same exact URL that you used for today's live event. This will be archived. It'll likely be up on the DBTA website tomorrow afternoon. And you will receive an email notification from us once it is posted. And if you would like a PDF of the deck, you can go to the handout section once that is live. Well, thank you everyone for joining us, and we hope to see you again soon. And happy holidays.
Thank you.
Thank you, everyone. Have a good one. Bye.